Okay, welcome back to another session for revising for your prelims. All right, so today we'll be just quickly summarizing ionic and covalent bonding. We will be going through once more how ions are formed, as well as how covalent bonds are formed. All right, and after this, in the last 10 minutes or so, we will do a quick revision of alkanes and alkenes before we break for the day. Now, so this summary we have already done in class. In class, I have made you actually draw out the dot and cross diagram for magnesium oxide. We said that magnesium oxide is an example of an ionic compound. This is because magnesium oxide is made of a metal, magnesium, and oxide, which comes from oxygen, which is a non-metal. So whenever you see metal and non-metal, this tells you the bonding must be ionic bonding. So ionic bonding exists because the metal loses valence electrons, the non-metal gains valence electrons. So let's go through this in detail once more. So if we know that it's magnesium, we go look for magnesium in the periodic table. If you look for magnesium in the periodic table, Mg has a proton number of 12. So if magnesium has a proton number of 12, this means that magnesium atoms also have 12 electrons. So this is the magnesium atom. The magnesium atom has 12 electrons. Therefore, the electronic structure is 282. 282. 12 electrons in total for the atom. However, 282 means it has 2 electrons in the valence or outer shell. This means that magnesium atoms are not stable. Magnesium atoms will therefore lose 2 outer electrons to form Mg2 plus ion. So it's important to know the difference between the words atoms and ions. Atoms is where the electron and the protons are same in number. Like magnesium. Magnesium atoms have 12 electrons and 12 protons. That's why atom is 282. However, the ion will not be 282 anymore. The ion is formed when the atom loses 2 valence electrons. Hence, the Mg2 plus ion is 28. Now we move to oxygen. So again, it's the same concept. When you are given oxide, you first go look for oxygen in the periodic table. You see that oxygen has a proton number of 8. This means that the oxygen atom has electronic configuration 2, 6. Because 2 plus 6 equals to 8 electrons. The oxygen atom has 8 electrons. Same as the number of protons. 8 electrons, 8 protons. However, 2, 6 is not stable. It has 6 outer electrons. It will gain 2 outer electrons. And this forms the oxide ion. So the oxide ion is not 2, 6. The oxide ion, after gaining the 2 outer electrons, becomes 2, 8. So it's very important that at this stage, we know the difference between atoms and ions. So just to summarize once more, atom is uncharged. There is no plus, no minus overall charge. In an atom, the proton number is equals to the electron number. So like magnesium, 12 electrons, 12 protons. Oxygen atom, 8 electrons, 8 protons. However, once you get to the ion, ions have charge. They can either be positively or negatively charged. If it's a positive ion, this is because the proton is more than the electron. If it's a negative ion, the proton is less than the electron. Okay, so let's quickly take down and ensure we know the difference between atoms and ions. Now in class, we have also drawn out what Mg2 plus ion, O2 minus ion looks like. So this is what the Mg2 plus ion looks like, 28. Then the O2 minus, also 28. But take note, the O2 minus, the electron gain must be in a different symbol. Okay, because ultimately the electron is gained from a different source. in this case, the electrons gained by oxygen came originally from magnesium. So magnesium loses the valence electrons, oxygen gains the valence electrons. So at this juncture, I will pause for a while for you to take down the difference between atoms and ions, for you to also understand and look at why the atoms form the ions, all right? Okay, so we have just gone through the key difference between atoms and ions. So please make sure you use these terms correctly, all right? Now, another commonly asked question at N level is, how does the magnesium atom form its ion? So this is a commonly asked question that you have encountered in your TYS. Explain or describe how an atom forms its ion. So in this case, let's use magnesium as an example. Now, magnesium atom, which is 282, has 2 valence electrons. Hence, the magnesium atom loses 2 valence electrons to form the Mg2 plus ion with a fully filled outer electron shell. Okay, so actually I'm just putting into words what we had drawn out just now. Importantly, you need to know and state how many valence electrons it has and whether it loses or gains the valence electrons. Finally, you need to clearly state that this is to achieve the fully filled outermost electron shell. So these are the key parts to your answer if you are asked how does an atom form the ion. Okay, tell me how many valence electrons is there. Tell me whether it loses or gains valence electrons. How many valence electrons are lost or gained. And finally, make sure you write down that the ion formed has a fully filled outer electron shell. Okay, so this is an example of how to tackle such a question. Okay, so please ensure you have taken this down. Okay, so that explains how atoms form the ions. Now let's look deeper at the properties of ionic compounds. Okay, so we have also gone through this very briefly in class. All right, the properties of ionic compounds. The first property of an ionic compound that you absolutely have to know is that ionic compounds have a high melting point. Okay, ionic compounds have a high melting as well as boiling point. Okay, so ionic compounds have high melting points. This means that they are solids at room temperature. Okay, so for example, magnesium oxide that we have just done, magnesium oxide has a very high melting point. Magnesium oxide melts at something like 2000 plus degrees Celsius. It's really high. And you need to be able to explain why. The explanation or the reason is that there are strong electrostatic forces of attraction between the ions, which require a lot of energy to overcome. Okay, so the important thing here is the strong electrostatic force of attraction, and it's between the ions. This is ionic compound, therefore they are ions. Mg2 plus is an ion, O2 minus is an ion. So these forces of attraction, you need to know they are electrostatic forces of attraction, and they are strong. Therefore, they require a lot of energy to overcome. Okay, and that's why to melt and to separate the ions to form a liquid or to form a gas, you actually need a lot of energy because of the very strong electrostatic forces of attraction. Okay, so please ensure you take this down, this explanation why ionic compounds have a high melting and boiling point. Now, the next physical property of an ionic compound, which many of you often forget, is the electrical conductivity. So ionic compounds have high electrical conductivity in the molten and aqueous states, but low conductivity in the solid state. So this question is about, does it conduct electricity? Ionic compounds will conduct electricity, but only in the molten and aqueous states. So what is molten and aqueous? Aqueous easy, this one AQ, you know. We went through yesterday. AQ means dissolved in water. Molten means liquid. It means that you have melted it down. All right. So why is it that ionic compounds are so special? Solid, they don't conduct. But when it's liquid or when it's aqueous, it conducts. So the reason is because there are free moving ions in the molten and aqueous states. Okay? There are free moving ions in the molten and aqueous states which can conduct electricity. But in the solid state, the ions are held in fixed positions. And are not free to move. Okay, so importantly, you need to state both. So in the molten and aqueous states, you have free moving ions. However, in the solid state, the ions are held in fixed positions and you cannot move freely. All right, so ensure that you have taken these explanations for both the melting point and the electrical conductivity down, and make sure you learn them before the exam, because these are things that you may forget quite easily. So it is important for us to learn before the exam, all right? Okay, so good. We have just went through the physical properties of ionic compounds, namely that they have high melting and boiling points, and also in terms of electrical conductivity, ionic compounds do not conduct electricity in the solid state. However, they conduct electricity well in the molten and aqueous states. So the explanations and reasons for each property is very, very important. Please make sure you know it. All right. Now, the final property is that ionic compounds are soluble in water. They dissolve in water, but they are insoluble in organic solvents. So for example, like oil, okay? Ionic compounds do not dissolve in oil. However, ionic compounds generally will dissolve well in water. Okay, this is just a property that you should know. Now, before we move on to covalent bonding, a little trick that you should definitely use in the exam is every single exam paper gives you a periodic table, right? So you are always given the periodic table in an exam paper. So when you are able to start writing, if the examiner says, okay, you may begin your examination now, the first thing you need to do is to go to the periodic table. Now, what do you do when you go to the periodic table? You notice that the periodic table is divided into groups and, of course, periods, right? So what I have shown you here, these are the groups. Okay, group 1, group 2, group 3, 4, 5, 6, 7, and finally 0. All right, so why did I show you the groups? Because I would like you, once you can start writing, once you start your exam, you go to the periodic table and you write this under every group. You write the charges of the ions. Group 1 will form 1 plus, group 2, 2 plus, group 3, 3 plus. Why? Group 1 loses 1 valence electron. Group 2 always loses 2 valence electrons. Finally, group 3 loses 3 valence electrons. All right. So that's group 1, group 2, group 3. This is what you write under the group number, so that it reminds you that every single element in this group should form an ion with this charge. Every single element should lose this number of valence electrons. Now, we are going to skip group 4. Okay, we'll just put a dash. Okay, we'll just skip group 4 and we'll go to group 5. Okay, now group 5 is 3 minus ion, group 6, 2 minus, group 7, 1 minus. Why? Group 5 has 5 valence electrons, so it will gain 3 to achieve a fully filled outermost electron shell. Group 6, like oxygen, gains 2. Group 7, chlorine, fluorine, they gain 1. So this is what you should label on your periodic table. Group 1, group 2, group 3, group 5, which is V, V stands for 5, group 5, group 6, group 7. Then we go to the group 0. Under group 0, you'll write noble gas. Now, I hope you know by now, noble gases are unreactive. They do not form bonds. All right, they don't have to lose, they don't have to gain, they don't have to share also. They are unreactive. Okay? Now, we are left with, of course, group 4. Now, under group 4, you will write mostly covalent bonds. Okay? So the group 4 elements are quite unique. Okay? The group 4 elements will be mostly covalent bonding for your syllabus. Okay? I don't mean that every single group 4 element forms covalent bonds, but for your syllabus, because we are only dealing with carbon, so group 4 forms covalent bonds. All right? So ensure that you know how to label the periodic table as such, so that you can maximize what you can get out of the periodic table. Okay? Now, another thing that you can label in your periodic table, which is in the middle, there's some space, right? The middle part between group 2 and group 3, there's some space. So this is where you write the ions that we did yesterday. Nitrate, hydroxide, sulfate, carbonate. Okay, finally, one last one, ammonium. So you basically write out from your memory, because these are things that you memorize before the exam. So you can write this out on the periodic table, of course, only after the examiner says you can begin. So you annotate all this on the periodic table so that you will not forget so easily. All right? Okay, so after annotating the periodic table as such, I hope that this is useful for you to actually remember the charges of the ions. Okay, remember, the periodic table must be used to the fullest extent you can use it for. Do not do a chemistry exam without looking at the periodic table. Okay, so that's ionic bonding. So we finished ionic bonding already. So just to recap, ionic bonding is between a metal and non-metal. Ionic compounds are formed by loss and gain of valence electrons. Okay, and ionic compounds have some special physical properties. Namely, ionic compounds have a high melting point as well as a high electrical conductivity in the molten and aqueous states, but not in the solid state. All right, now we shall move on to covalent bonding, which we have done many times. All right, so covalent bonding starts off by talking about molecules. Now, when you read this word molecule, you know immediately it's covalent bonding. Molecule, this word is only used when the atoms share valence electrons. All right, so chlorine. Chlorine forms a diatomic molecule because 2 atoms of chlorine are covalently bonded together. Now, how many electrons do they share? Well, we should know that chlorine, if you look in the periodic table, is 287. 7 valence electrons. If it has 7, it needs 1 more valence electron in order to achieve a fully filled outer electron shell. So if it needs 1 more, it shares 1. So sharing 1, 1 dot, 1 cross. Each atom shares 1 electron with each other. But that's not it. You must still fill up the remaining electrons outside. Now, how do you decide how many electrons to fill outside? The idea is it shares electrons to achieve a fully filled outer electron shell. Fully filled outer shell for chlorine means I need to have 8 electrons in total. So if there are already 2 shared electrons, you need to draw 6 more electrons, which are not shared outside in the outer shell. So this is of course showing outer electrons only. Okay, so the question will specify whether they want you to show all electrons or showing outer electrons only. Now this is chlorine, Cl2, it's diatomic. Of course, the next example that is very commonly tested, that you have seen so many times, is carbon dioxide molecule, right? So carbon dioxide is CO2. So again, the word molecule is used. This means that the bonding in CO2 is definitely covalent bonding. It involves sharing of the valence electrons. So how do we draw CO2? The principles are still the same. However, now you have 1 carbon, 2 oxygens, 1 C, 2 O. So we always put the 1 in smaller number. If you only have 1 carbon, put the carbon in the center. Then oxygen goes to the side. That's it. Next, you got to figure out how many electrons are being shared. We look at the one that is at the side, which is oxygen. Oxygen is 8 electrons, therefore 2, 6. 6 outer electrons. It requires 2 more electrons to achieve a fully filled outer electron shell. Right? 6 outer electrons, it needs 2 more electrons to achieve a fully filled outer shell. So if that's the case, if it needs 2 more, we share 2. Okay, so sharing 2, 1 dot, 1 cross, 1 dot, 1 cross. So it's like that. This is the meaning of sharing 2. It means that oxygen shares 2 electrons of its own. Carbon, in turn, shares 2 electrons of its own. Okay, 1 dot, 1 cross, 1 dot, 1 cross. Okay, but that's not it again. After you have established that it shares 2 electrons, therefore 1 dot, 1 cross, 1 dot, 1 cross, you need to fill up the valence shell. Okay, ensure that the valence shell has 8 electrons in total, including the shared electrons. Okay, and that gives you this dot and cross diagram for CO2. All right, so this is how we draw the dot and cross diagrams for covalent molecules. We consider how many electrons do they currently have in the outer electron shell. Based on the current number of outer electrons, we work out how many more electrons it needs. The number of electrons it needs is the number of electrons it will share. All right, so let's ensure that we take this down and we understand how to draw dot and cross diagrams for covalent molecules. Okay, so we have just gone through how to draw dot and cross diagrams for molecules. Remember, the word molecule is only used when there is covalent bonding. And covalent bonding involves the sharing of valence electrons between non-metal atoms. So you can see over here, these are all non-metals. Chlorine is a non-metal. Carbon and oxygen are also non-metals. So remember that non-metal and non-metal forms covalent molecules with covalent bonds. However, if there's a metal, that means it's not covalent, it's ionic bonding, which is like magnesium oxide, magnesium chloride. Okay? So ionic and covalent bonding represents 2 different opposite types of bonding. Now, what I have drawn here is the molecule. Okay? Now, let's just move on to the properties of covalent molecules or covalent substances. Now, remember, I just said that ionic and covalent, they are opposites of each other. And this also extends to their properties. So just now under ionic, we say that they have high melting point. Covalent is the opposite. They have low melting and boiling points. So covalent substances like CO2, Cl2, H2O, NH3. Okay, they all have low melting and boiling points, which means that they tend to be gases. Another word for this, volatile. Volatile means it tends to form a gas. And this is because the boiling point is very low. So this agrees with our understanding. We know that carbon dioxide is a gas. All right. Now, why is that the case? What is the reason for this? So again, whether something has a high or low melting point depends on the forces of attraction. So in a covalent substance, the force of attraction is called the weak intermolecular forces of attraction. Now, intermolecular forces of attraction are the weak forces between molecules. All right. So take note, you must use the words correctly. Over in covalent bonding, we say molecules. Okay. Because these are weak intermolecular forces of attraction, they only require a small amount of energy to overcome. So this is the exact opposite of ionic compounds. Ionic compounds is strong electrostatic forces of attraction between ions, needs a lot of energy to overcome. Covalent is weak intermolecular forces of attraction between molecules, which only require a small amount of energy to overcome. Okay, so this is exact opposite of the ionic compound. Next, okay, covalent substances, unlike ionic compounds, covalent substances do not conduct electricity in any state. So for example, CO2 is not a conductor of electricity, regardless whether it's a solid or a gas. The main reason is because there are no free moving ions or electrons that can conduct electricity. So CO2 has no free moving ions because it's not ionic. CO2 also doesn't have free moving electrons. The electrons are either being shared or the electrons are inside the electron shells. They cannot move freely outside of the CO2 molecule. All right, so ensure that you have taken these explanations down. Please note that this is really the reverse, the opposite of an ionic compound's properties. So you should treat ionic and covalent substances as really opposites of each other. Okay? Okay, so we have gone through properties of covalent substances, namely they have low melting and boiling points, as well as they do not conduct electricity at all in any state. Now, there is an exception to this rule though. The exception is that HCl, HNO3, H2SO4, these are all acids. So we remember hydrochloric acid is HCl, nitric acid HNO3, sulfuric acid H2SO4. These are covalent substances. They are covalent molecules. However, they do conduct electricity. And one more exception is ammonia. Ammonia is an alkali. Ammonia gas turns moist red litmus paper blue. All right. Now, so importantly, why is it that acids and alkali are an exception? Acids and alkali, they can dissolve in water. Dissolve in water means aqueous. So in the aqueous state, they produce H plus ions for the acids or OH minus ion if it's the alkali. So ammonia forms OH minus, whereas the other three acids form H plus. Now, these are ions and they are free to move. And because of this, these covalent molecules, they have free moving ions in the aqueous state, which can conduct electricity. Okay, so these are the exceptions to the property that we have listed. Most covalent molecules do not conduct electricity at all. However, let's take note that acids and alkalis, if they dissolve in water, they actually produce ions, which can move freely to conduct electricity. All right. Okay, and that really concludes our section on ionic and covalent bonding. So if you just look at the summary that you have copied down, we have covered quite a number of things. Number one, we have covered how ions are formed through loss and gain of valence electrons. We have also gone through how to draw dot and cross diagram from an ionic compound, such as MgO. We have gone through how to draw dot and cross diagrams for covalent molecules. Covalent molecules involve sharing of valence electrons. So it is important to know how many valence electrons are shared. Okay. Finally, we have gone through the properties of ionic compounds as well as the properties of covalent substances. So these two are really the opposites of each other. Important to know is the reason. How can I explain that ionic compounds have high melting point? How can I explain that covalent substances have low melting points? How can I explain electrical conductivity of ionic compounds? Okay. Now, before we move on, another important high-level thing that perhaps we should do now is to look at some more interesting things. So yesterday, when we were doing how to write equations, we came across this salt, right? This salt is called magnesium nitrate. Now, how would you make magnesium nitrate? So yesterday's lesson, we went through acid reactions. We have also gone through how to prepare salts. Namely, we need to know that magnesium nitrate is prepared using an acid called nitric acid. We need to use nitric acid because it's nitrate salt. Nitric acid forms the nitrate. Hydrochloric acid forms the chloride. Sulfuric acid forms the sulfate. Okay. Now, where will the magnesium come from though? The magnesium will come from excess magnesium metal, or as Mr. So usually prefers, I like to use the carbonate. So we use excess magnesium carbonate. We add it to nitric acid. It is important for the magnesium carbonate to be in excess. This is so that all the acid can be completely reacted away. All right, so this was what we covered under salt prep yesterday. And yesterday, we also covered how to write equations. So under the equation, we actually wrote down the formula for magnesium nitrate. Magnesium nitrate is Mg bracket NO32. Now, why is it bracket NO32? This is because we know that magnesium is from group 2. So group 2, 2 valence electrons, it loses 2 valence electrons. So it forms 2 plus. Nitrate, you got to memorize, it's NO3 with a 1 minus charge. Because 2 plus, 1 minus, therefore you need 2 nitrates to balance out 1 Mg2 plus ion. Now, why do we need brackets? So yesterday we also went through during the lesson. We will need brackets for nitrate, sulfate, this kind of ions, whenever you have 2 or more of it. Because we want to say that you have 2 nitrate. The whole nitrate is like a whole block, a whole unit. You need to bracket the whole block up. All right? So we put a bracket around the NO3 whenever there is 2 or more of it. Now, so let's link this to bonding. So what type of bonding is there in magnesium nitrate? So first things first, you see there's charge. Once you know there's charge, clearly there will be ionic bonding. Okay, ionic bonding exists between the Mg2 plus and the NO3 minus ion. That's ionic bonding. Okay, definitely got ionic bonding because it's ions. Magnesium ion, nitrate ion. However, how about inside the nitrate? Remember yesterday we said nitrate is NO3, right? That means there's more than one atom, inside the nitrate. There's nitrogen, one of it. There's 3 oxygens. How are the nitrogen and the 3 oxygens bonded together? Nitrogen and oxygen, right, in the nitrate. Then we think about it. Nitrogen and oxygen. Nitrogen is a non-metal. Oxygen is also a non-metal. So clearly, the bonding between nitrogen and oxygen is not ionic. They are non-metals. Therefore, the bonding between N and O inside the nitrate is covalent. And that's why we say that magnesium nitrate contains ionic bonds as well as covalent bonds. The ionic bonds are between the 2 ions. The covalent bonds is inside the nitrate between the N and the O. All right. So this concludes our study of bonding. I hope that, this has been useful for you. Remember all the tips that we went through today, hopefully it'll be useful for your prelims as well. Now, in the last 5 minutes of today's lesson, I would like to point us back to the summary that we have done for alkanes and alkenes. Now, this summary we have actually copied down in our notebook. It's the first summary that we did together in class. Okay, you can also find it in our contents library under topical revision. That's chapter 15, alkanes and alkenes. Now, why do I point us back to alkanes and alkenes? This is because I feel that organic chemistry is a huge part of the N-level syllabus and will take up many marks. Therefore, it is important that you actually revise organic chemistry thoroughly before you enter the exam hall every single time there's a chemistry paper. So let's go through alkanes and alkenes. Alkanes and alkenes are hydrocarbons. You need to know what's the definition of a hydrocarbon. Hydrocarbons are organic compounds that are made up of hydrogen and carbon atoms only. The keyword here is only. It can only have hydrogen and carbon inside the compound. It cannot have other things like oxygen, chlorine, bromine. All right, it must only be hydrogen and carbon strictly. All right, now alkanes are saturated. So hopefully you remember, saturated means there is no carbon-carbon double bond. On the other hand, alkenes have a carbon-carbon double bond. Therefore, they are unsaturated. So you need to be familiar with these words: saturated, unsaturated. Okay? Next, you must be familiar with the general formula. CnH2n plus 2. The one with plus 2 is alkane. All right? Alkene is just CnH2n. Okay? Now, how do I make use of this general formula we have gone through in class? So, for example, if I give you propane, pro means 3 carbon. 3 carbon means N equals to 3. So you sub in N equals to 3, you will get C3H8 for propane. For propene, it's a 3 carbon alkene. Therefore, CnH2n gives you C3H6 for propene. Now, a very quick way to tell from the formula if it's an alkene is to look at the number of hydrogen. If the number of hydrogen is twice the number of carbon, then it is an alkene. All right. So I hope that we already know how to draw alkanes and alkenes. If you are still unfamiliar, please make sure you revise before the exam. Now, important principle when drawing organic compounds, make sure that every carbon has 4 bonds. All right. You need to make sure that every single carbon atom has 4 lines, 4 bonds around it. Make sure you count properly. Don't be careless. Don't anyhow draw until there's more than 4 bonds. In particular, propene. The reason why we went through propene in class is because many students actually get propene's structural formula wrong. When they're asked to draw propene, they always draw it wrongly. Okay, which one is the one that's tricky? Is the carbon in the center. You need to realize the carbon in the center actually only has 1 hydrogen. This is because it needs to have only 4 bonds around itself. Okay. Now we move on to the reaction. So we have gone through combustion. Combustion, there's complete combustion, which takes place when the supply of oxygen or the supply of air is a lot of air, a lot of oxygen. Okay, so complete combustion produces only carbon dioxide and water. However, incomplete combustion, Incomplete combustion is when there's limited oxygen or limited air. When there's incomplete combustion, it produces carbon monoxide, soot, and water. So it is important to know the products formed during incomplete combustion. There are three. The three products are carbon monoxide, CO, soot, which is carbon, and water. All right. Now, alkanes undergo combustion. Alkenes also undergo combustion. So this reaction combustion is common to both alkanes and alkenes. However, alkanes undergo substitution in the presence of ultraviolet UV light. So under UV light, alkane undergoes substitution with chlorine gas. All right, you must be able to write the equation. I hope you recognize substitution. Substitution is where chlorine substitutes one of the hydrogen atoms in the alkane away. Now, this forms a chloroalkane and HCl. So there are two products on the right-hand side. So that's for alkane. Alkane undergoes substitution. So alkane A undergoes C, combustion, S, substitution. So ACS. Then you have alkene, ECA, combustion and addition. So you recognize an addition reaction because when you add something, there's only one product on the right-hand side of the arrow. So in particular, we can add hydrogen gas. This is called hydrogenation. Hydrogenation of the alkene, okay, converts the alkene to the alkane. Can you see the C3H6 plus H2 becomes C3H8? All right, and this process produces only one product on the right-hand side. So this is addition. Now, addition of hydrogen produces margarine. So this is used to make margarine. You need to know that margarine is made from addition. You also need to know what's the conditions for hydrogenation. Must memorize 200 degrees Celsius, nickel. Now, next, we can also add bromine. Now, this is particularly important because the addition of bromine is a useful test for the presence of carbon-carbon double bonds. So alkenes will react with aqueous bromine. Therefore, alkenes, which are unsaturated, will decolorize aqueous bromine from reddish brown to colorless. This is a very, very useful and important test. You need to know this test very well. All right, add aqueous bromine, and therefore it will decolorize aqueous bromine from reddish brown to colorless if it's unsaturated, if there's carbon-carbon double bond. All right, now, so we have learned unsaturated, but there's another word that you need to know, which is polyunsaturated. Unsaturated, you already learned, right? Poly means what? Many. In this case, more than one carbon, double bond. So the word polyunsaturated means the compound contains more than one. More than one what? Carbon-carbon double bond. Okay? Now, what is an example of something which is polyunsaturated? The best example is vegetable oil. Okay, vegetable oil contains polyunsaturated fats. This means that the fats contain more than one carbon-carbon double bond. Okay? So this is alkanes and alkenes, which takes up quite a fair bit of organic chem. Now, another summary that we did for organic chem was for the previous chapter, which is Intro to Organic Chem. So if we refer back to Intro to Organic Chem, this is where we did fractional distillation of crude oil, because we said that all your organic compounds containing carbon originated from crude oil, which is called petroleum. All right, and you need to do fractional distillation of crude oil in order to separate the fractions in crude oil. And each fraction has its own use. You need to memorize the uses of each fraction. Next, we also went through cracking. Cracking is the process that is used to convert your larger hydrocarbons to smaller hydrocarbons. And this is because smaller hydrocarbons have higher demand as fuels. All right, you need to remember the conditions for cracking, namely 600 degrees Celsius, aluminum oxide or silicon dioxide catalyst. And finally, you need to remember what is the property of members of the same homologous series. Same general formula, same chemical properties, same functional group. All right, so these are important things for us to take note of for tomorrow. All right, so this is a quick summary. These things we have summarized in class. So please make sure you study all the summaries. So just to actually highlight again, we have summarized alkanes and alkenes, intro to organic chem, metals, acids and bases, ionic and covalent bonding. All right. Of course, these are not all the chapters. If you go back to our content library, we have done a total of 15 chapters. So we should be studying all 15 chapters for the prelims as well as the N levels. Okay, so please make full use of the content library and the notes and summaries inside. Okay, very useful summaries to actually revise. Okay, thank you so much, and I'll stop the recording now. Thank you.